Hi, welcome to your MECH 200 Statics online classes. Today we're going to finish the content of Chapter 3. In this short video, our focus will be on three-dimensional problems involving the equilibrium of a particle. I hope you enjoy this class. Up to now, we have been learning how to model and solve statics problems involving the equilibrium state of a particle only when it's subjected to a coplanar or two-dimensional system of forces. However, the same concept can be extended to a particle subjected to a three-dimensional force system, in which the z-axis is added to the reference coordinate system, and we have to identify the forces and its components acting towards this direction. The same general equilibrium equation is valid for this situation. All we have to do is to find the components of the forces in all three directions by applying the same trigonometric relationships and the vector algebra rules we studied in previous chapters. Then we rewrite the equilibrium state equation in the Cartesian vector notation using the components we just found. And finally, we can break it down into three separate equilibrium equations, one for each direction, and solve them simultaneously in order to get whichever unknown forces acting in the particle. We can extend the same procedure of analysis presented for a coplanar force system to a three-dimensional force system. In this case, we always start by drawing the outline shape in a free body diagram, in which we establish first the x, y, and z axis, label all knowns and unknown force magnitudes and directions, and assume as positive the sense of the unknown forces. Then we have to turn our attention to the equations of equilibrium, in which we first decompose all forces along the x, y, and z axis, apply the scalar equations for equilibrium for each direction, and finally, for the calculation of the forces, we initially assume that they are positive or oriented through the positive direction of the respective axis, and check if it's correct after we get the results. Now it's time to work on one example. In example 3.5, we have the picture shown here in which a 90-pound load is suspended by a hook and supported by two cables, AC and AD, and a spring having stiffness of 500 pounds per foot. Then we are asked to determine the force in the cables AC and AD and the stretch of the spring for the equilibrium condition of the system. We start the solution of this problem with the free body diagram, which is going to look like this. We can observe that this diagram is centered at the knot A, at which all identified forces are applied: the 90-pound load, the force of the stretched spring, and the force in the cables AC and AD, that we will call here FC and FD respectively. Next, we move to the equilibrium equations, in which by inspection, each force can easily be resolved into its x, y, and z components, and therefore, the three scalar equations of equilibrium can be used. Here we are considering components directed along the positive axis as positive. In this system, we have three equations and three unknowns: Fc, Fd, and Fb. This last one is the force in the spring. Then we can solve those equations by simply playing with substitutions. For example, we can start by solving the third equation and get the force Fc directly. Then we can plug the result of Fc we just calculated into the first equation and get the result for Fd. And finally, we take the result for Fd and use it in the second equation to get the result for Fb. To calculate the stretch of the spring, we have to consider the linear spring equation, and by substituting the values of the spring stiffness and the force Fb, We get the result for the spring stretch of 0.416 foot. You are now ready to study examples 3.6, 3.7, and 3.8 of the textbook on your own. Once again, try to fully understand all steps presented to solve the examples before you start working on the practice problems of this chapter. And that's the end of chapter 3. Thanks for watching, and I'll see you in the next video.